I often find myself looking at restaurants on DoorDash or Uber Eats and being sort of paralyzed by choice. And oftentimes that just leads me to order from one of the same two or three places I always go for. But that doesn't stop me from wondering why a given restaurant might have the reviews they have. Is this place 2 stars because the food is bad, or have they just had bad luck with drivers that are late? Sometimes I might not care about the urgency, but sometimes though I just want to get something as quickly as possible and admittedly might not be as concerned with the quality of the food. Obviously, that information is pretty hard to convey with just a simple 1 to 5 star scale. And a big reason why restaurants aggregate to a simple 1 to 5 scale is just that it's easy. And asking users to fill out a whole survey for every item they ordered and their whole experience is obviously impractical. That being said, people love to give their opinions, and when they're provided a free text box to share their thoughts, they often will. There are plenty of open response reviews for many restaurants across different platforms, and I feel like the information hidden in those reviews is really going underutilized, both by users and the platforms themselves. And that got me thinking, can we extract meaningful information from text reviews and turn these into a more robust, more valuable rating system? One that displays a restaurant's quality across a variety of features, not just overall. And more specifically, can we use a predictive model to extract information about the quality of the food, the accuracy of the order, and the delivery experience? I'm going to outline the process I took to do exactly that and share some of the roadblocks I hit, the unexpected findings I uncovered, and of course the final outputs. As with all AI/ML projects, the first step is always to get your hands on data, often as much as is possible. And that's honestly immediately where I hit my first roadblock. I spent some time exploring Uber Eats, Postmates, DoorDash, and started to worry that customer reviews were not going to be accessible to end users, or at least the free text responses. I could not find a way to access these on any platform, and eventually got lucky with Grubhub, which provides an easy way to view all user reviews for a given restaurant. So at this point, it was really just a matter of creating a quick script to scrape all of the reviews for a given restaurant. I then iterated through about 50 restaurants local to me, pulling a total of about 9,000 reviews for a base data set. After some cleanup, here's what that data looks like. So we've got the link to the restaurant. We have some CSS info that we can extract the user's star rating from. We have the text review itself. And lastly, I also just created a column to count the number of words in the review. I was curious if maybe this would provide some insight later on. With our data in hand, it's time to start making predictions. But what's our best approach here? I ended up using an algorithm called Label2Vec. Label2Vec is an unsupervised algorithm for making text classifications specifically designed for document classification. And that felt close enough to what I needed to give this a shot. This library is built on a really interesting idea. You can represent an abstract concept or topic using a series of semantically similar terms. In more casual language, really what that means is that Label2Vec creates a complex web of the English language to understand how close certain words are to each other. And we'll get more into that in a second. Another big advantage of Label2Vec is that it's unsupervised. And that really just means that we don't need to manually go through all 9,000 reviews to determine whether they're about food quality, order accuracy, and delivery experience and label each one. The algorithm can determine that on its own without providing a bunch of manually tracked examples. Label2Vec requires that we give it some seed words to build out its understanding of our core topics. And I kind of just approached this intuitively for the first attempt, both coming up with words that I thought might be relevant to each category and also reading through a lot of reviews to see which words came up frequently. This ended up being honestly a really fun exercise to come up with these terms. It almost felt like sort of like a creative writing exercise in high school or something like that. So here's the first version of my keyword arrays, and quick spoiler that we end up tweaking these quite a bit by the end. So here's the basic skeleton of our model. It can score 9,000 reviews in a few seconds, but that doesn't feel like a great place to end this project. How do we know if the model is actually doing what it's supposed to? How do we know if it's actually good at what it's doing? And how do we know if there's anywhere we can improve it? We can answer both of these questions with something called a confusion matrix. I spent about 15 minutes reading through maybe 2 or 3% of the reviews and manually labeling them with the correct category, so we could see if the model is reaching the same conclusions. My thought process is that if a human being thinks the review is about order accuracy and so does the model, that's a pretty good sign. This is a super common means of understanding how classification models are performing. It can be interpreted by viewing the columns at the top as the category that the model predicted and the rows along the side as the actual true category for each review. For example, this box right here shows us that our model classified 83 actual order accuracy reviews as order accuracy reviews, or in other words, it classified them correctly. Alternatively though, this box means that we classified 10 actual food quality reviews as order accuracy reviews, so inaccurately. Ideally, we want to see the big numbers on the diagonals where the row numbers and column numbers are the same. I won't get into the math right now, but we can use the confusion matrix to generate something called an F1 score, and this score is super helpful for understanding how accurate our model is in aggregate. Our initial model has an F1 score of 0.49, and it's important to mention that this score isn't really super useful or telling as a one-off score. What does 0.49 mean exactly? Its real value is in understanding if future tweaks are making our model better or worse. So I kept going back to the list of keywords, adding, removing, and tweaking word choices, and I learned two big things from doing this. First is that more keywords does not mean better accuracy. I had a lot more success very deliberately choosing a small subset of words than throwing everything I could think into the categories. And the second thing I learned was it was imperative that the words chosen for a particular category were completely unrelated to the other two categories. For example, a word like soggy being used in a review could be due to poor food quality or the food taking too long to deliver, and this would really muddy the delineation between the two categories. So for this reason, that word shouldn't be included in either category. Focusing on just these two findings really helped me shape my final list, and this is what I ended up using. Here's our trusty confusion matrix again, and we can see that our F1 score has gone from 0.49 all the way up to 0.72. And of course, this isn't perfect, but I was happy to see that our model could accurately predict all three categories much more frequently than it got them wrong. The last thing I wanted to do is develop a means of displaying this info visually. The star system works when every restaurant just has a single number from 1 to 5, but even in our simple 3-dimensional system we created, that info would become just visually overwhelming. So I experimented a bit and ultimately landed on using polar charts to compare restaurants. Here's what a comparison of 3 restaurants looks like in our system, and there's a couple interesting points that I want to call out here. First, I really like the idea that a restaurant's overall quality is tied to the total area on the chart that it occupies, and that different spikes can be evaluated together or as individual components. Second, I noticed that delivery experience reviews are almost always lower than the other two categories, and this makes sense to me. I find it hard to believe that there are many reviews raving about the delivery experience. You're probably only likely to hear about it when the delivery experience was negative. Food quality, on the other hand, lends itself to more positive language if somebody really enjoyed what they ate. So how does one use all this new information? As alluded to at the beginning, there are some days where I want to order food and get something really great, and there are some days where I'm just hungry and tired, and maybe food quality is less important. And using this info, I can understand for any given restaurant whether their food is high quality or whether they complete orders quickly. On a more serious note, it's also good to acknowledge that food delivery apps can be absolutely brutal for new businesses. A couple bad reviews early on can bury a new business, dooming them to a place far down the list of their local competitors. And these reviews might not have anything to do with the food. It may just be attributed to the driver picking up the order. I feel as though a filter like this being available to the end user to prioritize reviews regarding food quality could do a lot to combat this problem. Anyways, that's the project. There is plenty of nuance here that I did not get into, like the ability for our model to classify a review that mentions 2 different categories, or the ability for the model to highlight maybe specific items on the menu, but we can leave those for another time. Thanks for listening to me ramble about food reviews and machine learning. If this is your thing, please consider liking the video and subscribing. I have a handful of similar machine learning and AI videos about weird niche topics like this in the works. If you're interested in recreating this work for restaurants local to you, I'll throw the notebook I created in the description below. Thanks again.